Hi, welcome to video 8.3b, more trig integrals. So now we're going to move from sine and cosine to either a combo of tan and secant or a combo of cotan and cosecant. And you'll see why in a second. So here's an example, tan cubed x, integral tan cubed x, secant squared x dx. Okay, always first you want to pick out a good du. And if you remember your du's, the derivative of tan is secant squared. So you will purposely pull out a good du, which in this case is a secant squared. Other good du's, by the way, in the future will be secant tan, because that's the derivative of secant. Derivative of cosecant is negative cosecant squared, so cosecant squared would be something good to pull out as a du. And the derivative of cosecant is negative cosecant cotan. But you've got to pull out that du first. It's like the tail that wags the dog. Okay, so we're pulling out a secant squared x dx because that's a good du. It's a du of what? It's a derivative of tan. Sure enough, that's what we have. And basically you're looking at u cubed du, which is u to the fourth over 4 plus c, which ends up being a very easy tan to the fourth over 4 plus c. Okay, so not very difficult. So here's the deal. If your secant is an even power, you'll easily be able to pull out a secant squared, which will leave you another even powered secant. And then remember, there is a relationship between tan and secant, and that is that tan squared plus 1 is secant squared. So, for example, here what you'll do is you'll pull off a secant squared, because that's a good du, leaving you with another secant squared. Now, secant squared is the derivative of tan, so you want all of this to be in terms of tan. Well, you already have tan cubed, but you need to have secant squared in terms of tan. But of course, secant squared is 1 plus tan squared. We then distribute. We have tan cubed plus tan to the fifth, which gives us u cubed plus u to the fifth du, which gives us u to the fourth over 4 plus u to the sixth over 6, which is tan to the fourth over 4 plus tan to the sixth over 6 plus c. So again, just to remind you, what are the good du's? Derivative of cos is negative sine, derivative of sine is cos. These are all your good du's. Also, you should know your trig identities. Sine squared plus cos squared is 1, which implies cos squared is 1 minus sine squared, etc., etc., etc. And so here's another one, tan to the fifth. So now it's a tan all by itself. Now what you're going to have to do here is you're going to pull out a tan squared. Not that tan squared is a good derivative, but secant squared is. So you'll take the tan to the fifth, break it up into tan cubed times tan squared, purposely change tan squared into secant squared minus 1, because if tan squared plus 1 is secant squared, then tan squared is secant squared minus 1. Now what you'll do is you'll multiply through. You'll have tan cubed times secant squared minus tan cubed. And now you have basically over here u cubed du, except for the derivative of that x to the fourth will be 1/4. So derivative of tan x over 4, is secant squared x over 4 times the derivative by chain rule. So we do have to introduce a quarter counteract with a 4. But at this point, you're integrating u cubed du. Now, you will have to do it again over here. You'll break up the tan cubed into tan squared and tan. Again, you'll replace the tan squared by secant squared minus 1. Again, you will distribute. And eventually, you'll end up with tan to the fourth minus 4. And then this is just the integral of u du. But what happens over here is you will end up with that ln minus ln cosine or plus ln secant when you integrate just the tan. Now, another way to look at this is you could have broken it up into tan times tan to the fourth. The tan to the fourth would be the square of tan squared. Again, tan squared is not a good du, but its cousin is secant squared minus 1. You will then square the secant squared minus 1. You will get square double product square. You will distribute. And once again, you will be able to, in this case, you'll actually be able to pull out a tan and a secant, giving you the secant tan du. So leaving you with another secant cubed over here. Over here, the derivative of tan is secant squared. You're just missing the quarter. And of course, again, we're integrating just tan, which is negative ln cosine. Over here, I have secant cubed times secant tan, which is u cubed du, and you should be able to take it from there. So again, the tail is the most important part of all. It's what are you pulling off for your du. So what are the things that are good? Secant squared, secant tan, cosecant cotan. So again, we saw that if you have a tan to an even, you can pull out a tan squared, replace that by secant squared minus 1, and then you're on your way.